So today we're going to review how to solve quadratic equations. And we're going to do it by one of these three methods. The first one is we're always going to try to do it by factoring first. That's the easiest and quickest way. The second way is the square root method. Remember, you can only do the square root method if you only have a quadratic equation that only has an x squared term, that doesn't have a linear term. And then the third way is the quadratic formula, and it always works. We're not going to do it by graphing today. So let's see, let's look at this first equation. So your first step is to get it into standard form. Again, this is standard form. So your first step is always write the equation in standard form. So our equation is already in standard form. So we're going to try to do it by factoring first. So we want to know, can I factor this? Well, it is a quadratic and it's a trinomial. And what's nice about it, it has a leading coefficient of 1. So let's see if it can be factored. Since it has a leading coefficient of 1, we're going to put x and x down. X times x gives you x squared. Now I'm going to look at the last number. I'm going to look at factors of negative 15. I'm looking for factors of negative 15 that add to be the middle number. Are there two numbers that multiply be negative 15 and add to be 2? Yes. Positive 5 and negative 3. So it can be factored. So this quadratic equation, we're going to solve it by factoring. Because we can factor. So what are the roots? What are the solutions? What are the zeros? Remember, roots, solutions, zeros, they all mean the same thing. So once you have a factor, you set the factors equal to 0. And then solve. So minus 5, x equals negative 5 is a root, or a 0. Add 3, x equals 3. So the roots, the solutions, the zeros of this quadratic equation are negative 5 and 3. All right, let's look at example 2 here. We want to try to solve it by factoring. Again, we got a quadratic trinomial. We have a leading coefficient of 1. So let's put x and x down. Now, let's look at the last number. I got to look at factors of 7 that add to be 3. So factors of 7 are 1 and 7, and negative 1 and negative 7. If you multiply 1 times 7, you get 7. You take negative 1 times negative 7, you get 7. Do any of these factors add up to be 3? No. So we can't do it by factoring. So we're going to have to try a different way. So let's try our second way. Can I solve it by the square root method? Well, to use the square root method, it has to be in this form. Okay? It can't have a quadratic, a linear term. It has a linear term. So the square root method is ruled out. So the way that we have to solve it is by the quadratic formula. Remember, the quadratic formula is negative b, or the opposite of b, plus or minus b squared minus 4 times a times c over 2a. So let's identify our values of a, b, and c. So a is the coefficient of your x squared term, so a is 1. B is 3, C is 7. So we got negative B, the opposite of B, so negative 3, plus or minus B squared. So 3 squared is 9, minus 4 times A times C, all over 2 times A. So let's work this out. 2 times 1 is 2. Let's figure out what's under the square root. So we got our 9. And let's go -4 times 1 is -4 times 7 is -28. We got 9 minus 28. 9 minus 28. What does that give us? That gives us -19. Now, up to this point, when we got a negative under the radical, we wrote no real solution. And we were done with the problem. But yesterday, we learned about imaginary numbers. So we can find the solution to this. The solution is not a real number, it's an imaginary number. Okay? So we got to simplify the square root of -19. Well, I can break that down to the square root of -1 times the square root of 19. Does 19 have a perfect square that goes into it? No. So the square root of 19 can't be reduced. What's the square root of -1? I. So my solution to this quadratic equation is -3 plus or minus I, square root of 19 over 2. And again, if I wanted to, I could write it out twice. I could write it as -3 plus I, radical 19 over 2. And the other root would have been -3 minus I, radical 19 over 2. Now, if we did do Desmos, okay, what would happen is we would get a parabola that doesn't intersect the x-axis. Okay, so it has an imaginary x-intercept, imaginary 0. It doesn't intersect it. All right, let's try another example. Here is my quadratic equation. Well, the first thing I notice, it only has an x squared. So if you ever happen to have an equation, a quadratic equation that only has an x squared, you're going to use the square root method. That's going to be the quickest and easiest way to solve it. Okay? You could do the quadratic formula, because that always works, but it's not going to be the quickest and easiest. So what we do to do the square root method is just get the x squared by itself. So I'm going to subtract 48 from both sides. So when I do that, I get 2x squared equals -48. Divide by 2. Divide by 2. X squared is equal to -24. Now we take the square root of both sides. So we want to take the square root of both sides. The square root of x squared is x. And remember, whenever you use the square root method, you got to put plus and minus on your answer. So my answer is x equals plus or minus the square root of -24. But you can't have a negative under a radical, so I'm going to pull out a -1, the square root of -1. Now let's look at 24. Does 24 have a perfect square that goes into it? It does. So I can rewrite this as -1, and the perfect square that goes into 24 evenly is 4. 4 times 6 is 24. So my solution would be x equals plus or minus, let's do the square root of 4 first, which is 2. The square root of -1 is I, and then I got my square root of 6. Again, this is just shorthand notation. This is really 2I radical 6 and -2I radical 6 are your roots. All right, let's do one last example. All right, so we should always, when we got a quadratic equation, let's always try to do by factoring first if we can. So, can this side be factored? Well, I don't have a leading coefficient of 1. My leading coefficient is 3. So if I want to factor this, I'm going to try to do the slip and slide method. So again, the slip and slide method is you take the 3, you slip it to the back, you multiply by the last number, which is -5. That gives me -15. So So now I'm going to try to factor this equation. So we'll put x and x now. So that gives me x squared. What two numbers multiply to be negative 15 and add to be 14? Positive 15 and negative 1. Again, what are we using? We're using slip and slide. What did we do? We did the slip part. So now I got to slide my 3 back into the problem. And then reduce these fractions. So 15 over 3 reduces down to 5. 1/3 can't be reduced. But remember, we don't want to leave the fraction there. So let's take this 3 and move it in front of the x. So we get 3x minus 1. So now we got it factored. So now we can set each of the factors equal to 0 and then solve. So one of the roots is negative 5. The other root would be 1/3. If you were to graph these, this is where your graph would intersect the x-axis at negative 5 and 1/3. These are the roots. These are the zeros. So again, when you're doing today's assignment, go through these methods. See which method is going to be the best one to use. If you want, you can always use this. This method always works. But these first two don't always work. But if they do work, they're going to be the fastest and easiest way to do it.